Hey guys, welcome to a short video tutorial on today's lesson. In today's lesson we were talking about polygon congruence and how do we tell if two polygons are congruent and what does that tell us. So if we look at these two pairs of triangles, if we look at this triangle DEF and triangle UVW, if you look at those two triangles, do they look like they are congruent to you? Take a moment to think about that. And then look at this pair of triangles here, triangle ABC, triangle YXZ, or XYZ, and are these two triangles congruent to each other? Okay, so you probably figured out that these two polygons, these two triangles are not congruent. And why is that? Because if you map this triangle onto this triangle here, in other words, if you move one of the triangles so it's right on top of the other triangle, it doesn't fit. You can see that the two shapes are not congruent. And what specifically is different about them? The side lengths are different. Okay, versus these two triangles, you can move one of these triangles, slide it over, and it will fit exactly on top of the other triangle. And so I want you to think about polygon congruence as, can you move one of the polygons so that it sits right on top of the other polygon, like these two? So if I told you that these two polygons are congruent, it doesn't matter if, let's say, one is facing this way and one is facing that way. Can you move one of these so that it maps right on top of the other one? Can you do a series of rigid motions? Rigid meaning you don't change the size of the angles or the length of the sides. Can you move one of these shapes so it maps on top of the other? And you can. Here you could do a rotation, and then you could do a translation, a horizontal translation to the right, and it would map right on top of it. So rotations and translations, meaning turning polygons and sliding them left and right or up and down, are rigid motions. The other rigid motion is what's called reflection, which you might think of as a flip. So you might have shapes like this, and you might have to rotate, translate, and flip or reflect. Okay? And those are all rigid motions. So if you can perform a series of rigid motions to map one figure on top of another, then the two figures are congruent. And given that these two figures are congruent, what do we know? We know that all of their corresponding angles are congruent and all their corresponding sides are congruent. So we know lots of things because in one triangle we have 3 angles and 3 sides. So it has 6 parts. So if these two triangles are congruent, then we know that 6 congruent statements are true, or 6 parts are congruent. Right? And here they are. We know that angle A matches with angle Y, angle B matches with angle X, and angle C matches with angle Z. We also know that side AC matches with side YZ, side BC or segment BC matches with or is congruent to segment XZ, and side BA is congruent to side XY. So we can make a couple different statements. We can say that triangle ABC is congruent to triangle YXZ. Notice we have to match the A matches the Y, B matches X, and C matches Z. But we don't have to name this triangle ABC. We could name it triangle CBA. And so what would triangle CBA be congruent to? It would be congruent to triangle ZXY. The C matches Z, B matches X, and A matches Y. So a couple things to note. One is that if you just look at the statement here, the C matches the Z, the B matches the X, the A matches the Y, but also notice that these two letters next to each other, CB matches these two letters next to each other, XZ, or ZX, excuse me. And in the same way, BA matches XY, and CA matches ZY. So those are all in order. Another thing that can help you is to go ahead and make congruence marks. So we know that angle A matches with angle Y. Angle B, let's make two congruence marks there, matches with angle X. And angle C matches with angle Z. So those are a couple really important strategies when we're dealing with congruent polygons. Either using the congruent symbols to match up the congruent parts, or also reading this statement and noticing that corresponding sides are in corresponding positions. Okay? And corresponding angles are in corresponding positions as well. Okay, hope this video helps, and good luck with this unit.